All right, pre-algebra, here we go. We're starting in with day one notes. This is meant to be in tandem with your pair deck to take notes. If you'd rather, you can take your notes in OneNote, but then you have a lot of little links. You're going to have to make sure that you click to where you can actually show me that you're doing the practice. All right, so the real number system, that's where we're going to start, just the real numbers. Right now in pre-algebra, we're going to work with the real number system. The other option would be, to be quite honest with you, it's out here and it's called the imaginary. So you see there's some jokes out there, some like cartoons out there that are mathy, and you might not catch them if they are like working with imaginary, and it's like with little I, okay? All right, so imaginary is going to have a little I. The real number system is where we're going to work. The real numbers are things that we can actually count, okay? So we're going to call these the real numbers, and let's give them a big R for real. And sometimes you can, like, all real numbers, it would be like that fancy-dancy R. And the real numbers are going to be a variety of numbers. We're going to come back to that. So irrational numbers, let's call those I. Okay, irrational numbers are numbers that do not terminate, and nor do they repeat. So they don't terminate or repeat. Decimals, and I have it here, never end or have no pattern. And think mumbo jumbo numbers, like they're kind of crazy numbers. For instance, pi. Pi is irrational. The square root of, I want to say the square root of 3 or 2 even, might be irrational. It doesn't come out pretty. Now, rational numbers, this is where we're going to focus, okay? So we're going to focus right over here on rationals. So we're going to do real, we're going to get real, do rationals. And rational numbers are numbers that you can make sense of. You might not like them, but you can make sense of them. And I'm going to actually take a little break and come all the way down to the bottom. This is where we started learning number system. When you were little, or you have little brothers or sisters or nieces or nephews, cousins, and you basically start doing the whole, like, here's 1, 2, like, how old are you? And they have to just hold up fingers. That's the natural numbers. That's going to be, we're going to call those N, and there's going to be like 1, 2, 3, 4, etc. They're numbers that little kids can start attaching, like one item to the number 1. Then we have whole numbers. Let's put whole numbers as a W. And W is going to be their whole numbers, but they're the natural numbers, including 0. So 0, 1, 2, 3, etc. And then we have integers. Integers are we're going to call those Z. And I don't know why they call them Z. They just call them Z. So the integers are going to be negative and positives. So let's do ... negative 3, negative 2, negative 1, 0, 1, 2, 3, ... So if you notice, it includes the 0 and the 1, 2, 3 is the positive. So we have the counting, natural numbers. We have the whole numbers, which include the 0. And now all we're doing is we already have that part. We're going to just include those negatives to make them integers. And then we have rational numbers. We already have an I over here for irrational, so that's why we use Z. We have an R up here for real numbers, so we're going to do something different for rational numbers. So as we continue, okay, so let's go ahead and look at rational numbers here. We're going to call rational numbers Q. Again, the reason we're doing that is we already have an R for real. So rational numbers are going to be numbers that are positive or negative, and they can be fractions, decimals, etc. So let's try like negative 2 1/3. Let's do the square root of 9, because the square root of 9 we know is 3. We could have the square root of 1 over 36, because the square root of 1 over 36 is actually 1/6. We could have the negative square root of 4, because we know the square root of 4 is 2, so the negative of that would be negative 2. We could also have the number 3. It's a rational number. Over here on irrationals, again, just to refresh your memory, irrationals are things that don't repeat or don't have a particular pattern. I'm going to tell you it's going to be non-perfect square roots. For instance, the square root of 2. Okay, so we're going to include those. That's kind of just a tidbit for you. And then the real numbers. Real numbers are anything. It can be everything from pi to the square root of 81. Oops, my pen's not doing nicely for me today. To 6 or negative 1. There you go. So now below, what you're going to do is the numbers on the classified as irrational, rational, and then if rational, you're going to ask 4 questions. The 4 questions you're going to ask are, and I'm going to start from the bottom. Is it a natural number? Natural. You're going to ask if it's whole, because if it is, then go to the whole. If it's natural and it's whole, check to see if it's an integer. And if it's natural, whole, integer, then it's just a rational number. Is it a fraction? Because if it's a fraction or a decimal, it might just be just the rational. So we're going to really start with, if it's rational, you're actually going to want to answer 3 questions. And so that's where we're going to end. So start at the bottom and work your way up. Bottoms up. All right, so we've already told ourselves we don't need that one. So where to start? Go with that natural number. Is it a natural number? Yes. So write n. Is it a whole number? Yep. Is it an integer, positive or negative? Yes. Now it's 30, so it's not negative, but it's still an integer. And it is also a rational number. So we can do a little rational number of q. So I work from the bottom up. So it's not like number 2 is not natural. Is it whole? 0 and then the positives? Nope. But isn't it integer? Yes. So we're going to start with integers right here, negatives. Negative pretty numbers. So we're going to call it an integer, which is a z. And then we also know if it's an integer, it's also rational, which is going to be q. The next one's a fraction. So I can like skip right up the line. Okay? It's not, it's rational. So it's just going to be q. Now all of these are going to be real. So if you want to put an R on all of them, absolutely. So they're real. What's a real number? None of these have an I on them. Now, go with the next one over here, the square root of 21. Well, we know the square root of 16 is 4, so 5 squared would be 25. So it's in between 4 squared and 5 squared, or 16 and 25. So it's a non-perfect square. So this one's going to be irrational. 0. 0 cannot be with our natural numbers, but it can be in our whole numbers, and then all the rest. So W, Z, Q, R. W, Q, oops. W, Z, Q. Negative radical 9. Well, radical 9 means 3, so this really is equal to negative 3. So negative 3, that kind of is a game changer, huh? Negative 3 starts with integer, so we know it's integer and rational. So integer, oops, we can't use I, can we? integer and rational. So Z and Q. 6 over 3. Well, 6 over 3 reduces because 6 can be divided by 3 evenly, so that's actually 2. Well, the number 2 is everything, the natural. It's, give it the grandpapa here, natural, whole, integer, and it is rational. Pi, we know, is irrational. And then this is a repeating decimal. Okay, repeating decimal is actually, if it's 0.3 repeating, that's actually 5 3/9, which actually gives me 5 1/3. So it's a nice fraction, so it's a rational number. It's not an integer. Make that a nice Q. It's not an integer because it has a fraction or a decimal behind it. However, it is a rational number. Okay, on this next little set, I would like you to place the letter, so the letter of each of these right here. I want you to put those where they belong. So if A belongs here, and try to keep them somewhat organized so that I can read them, all right? Try those on your own. Toyo, try on your own. Now we have some structure here, so pause me and do that. I do want you to transfer this over onto your Pear Deck as well, so I can see it there. So I prefer you to actually using your Pear Deck as your note-taking structure. So now we have the order of operations. Order of operations, we have parentheses P, E, M, D, A, S, F, B. Hopefully you guys know why I group multiply and divide and add and subtract, but I'll just go through that again with you. So please is actually parentheses. So if there's an operation to do in the parentheses, okay? Now our operations are adding, subtracting, multiplying, and dividing. Notice I'm trying to use an asterisk or a big dot for my multiplication rather than using, or even parentheses, or I can do 2 things like that. So like 3 and 4 in parentheses to show multiplication. The X sign here in pre-algebra is going to start looking a lot like the time sign and X. They kind of get confused. So I'm going to try to steer away from those. So now we have XQs. That's going to be your exponents. That's those little numbers. So if I have like X to the nth power, that's my exponent. And if I have, for instance, 3 to the 2nd power, that means 3 times 3, which is actually 9. The top number tells me how many of the base I'm going to have. My dear, I'm going to put those together, is whichever you get to first from left to right, multiply or divide. So this is multiply or divide in order from left to right. Same thing here for your Aunt Sally. Aunt Sally, and I do have an Aunt Sally, by the way. Aunt Sally or Aunt Sally, depending on how you say it, is your addition and subtraction. I guess I should have written multiplication or division, but you know what I mean. So here I am, and it's again going to be in order from left to right. I'd really like you to try these without your calculator, just because I want to see what you can do on your own. The last part here is that forebelching. A lot of you have not seen the forebelching before, but that basically is saying the fraction bar. So you'll complete the top, complete the bottom, and then you'll actually divide that piece out. So simplify top, simplify bottom, and then reduce or divide. So here we have some examples. I would like you to try them on your own. So pause me, try them, and then come back. Again, these 4 problems are in your Pear Deck. All right. So as we evaluate these, we're going to do order of operations. And I will let you know this is an addition sign, whereas this is a division sign. So my problem here says I need to go, please excuse my dear Aunt Sally. So parentheses, well, there's no operation inside of that parenthesis. So I'm going to go down to exponents. I don't have any exponents. So now I'm going to go multiply or divide. And as I look at this for multiplication or division, I actually have this as addition, and then I have division right here. And then I have multiplication. So I'm going to do this division piece first. So 54 divided by 3. Well, if I don't know how to do that in my head, I'm going to go 54 divided by 3 gives me 1, 3, 2 left over, bring down the 4, so it's 24 is 18. So I have 7 plus 18 now times 2. The next thing I'm going to do is this part. So I'm going to have 7 plus, because that's multiplication. 18 times 2 is 36. And then I'm going to simplify at the very end. So it's 36 plus 7. I always start with the bigger if you're just adding. Start with the bigger number and add on. So 36, 37, 38, 39, 40, 41, 42, 43. Number 2. I do have an exponent in here. And I have some multiplication. So parentheses, nope, exponents, yes. So 4 squared. 4 squared is 16. So I'm going to have 24 minus 16 times 3 plus 15. Next time through, I'm going to start at the beginning and work my way across. And I'm going to do this part because it's multiplication. So 24 minus, well, 16 times 3 is 18. 3, 4 would be 48 plus 15. Again, start back at the front. And in this case, we get to subtraction before we get to the addition, but that's okay because they're at the same level. So 24 minus 48. This is where some of you are going to get like, oh, wait, I have not done this. You can actually go into the negative. So 24 minus 48 gives me negative 24 plus 15. So if you owe me $24 and you give me 15 of them, okay? So if you, even if you think about a number line, or if you can think of where you would be in the back and coming right 15 steps, or since they're different signs, subtract the numbers and keep the sign of the larger absolute value number, which is the 24, so it's negative. And so find the difference between them. And that's going to give me 9, so negative 9. This next set, I threw in a little bit of absolute value for you. All right, so we have absolute value is actually a grouping symbol. So it's going to be considered a parenthesis. So we're going to take care of that first. Now, I'm not sure if you guys know about absolute value, but that's what's coming next. So I'll give you a little heads up. So absolute value of negative 18 is really just the number itself, just 18, okay? Because it means it's the distance from a center point, just the distance. So it's 18. So we're going to have 9 squared plus 28 divided by 4 minus the absolute value here of negative 18 is just 18. But it has a negative out front of that, so keep it. Now come back and do exponents. So this is 81 plus 28 divided by 4 minus 18. So I'm doing that one next. The next piece we're going to do is the division, because it's addition, division, and subtraction. So we're going to go multiply or divide, so divide. So 81 plus And 28 divided by 4 is 7 minus 18. Now, in order from left to right, we're going to add. So 81 plus 7 is 88. And then subtract 18. Now, 88 minus 18, well, 88 minus 8 would be 80. Minus 10 more is going to be 70. That one was a long one. Stick with me because I'm going to kind of keep going through these types of problems with you. The next one here we have parentheses, and in that parentheses, let's see. I have a divide by, and it's 2 to the 5th. Oops. So 48 divided by 2 to the 5th minus 29. Well, 2 to the 5th means 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. That's 4 times 2 is 8 times 2 is 16 times 2 is 32. So 48 divided by, in parentheses, 32 minus 29 plus 6 squared. So now I can still do the other the other squaring, which is over here. So 48. Ooh, go back. You guys are right. I'm thinking, I'm getting you off. Let's finish this up. So it's divided by 32 minus 29. Well, that gives me 12. 12 minus 9 is 3. That's 2, so it's just going to be 3. Plus, now we can do the 6 squared. All right, so now go back to the beginning, and we're going to do, so we took care of that one. Exponents are next. So it's going to be 48 divided by 3 plus 6 squared means 6 times 6, which is 36. Now we're going to go back to the front. We're going to go with multiply and divide. So 48 divided by 3 is going to be 1. 3 goes into 4 once with 1 left over. 18. 3 goes in there 6 times. Plus 36. And we add those together, and I will get, let's see, 36, 16, 12, 3, 4, 5. So 52. Now, some of those you may have thought were a little bit hard, but that's okay. I'm going to back it off, and you're going to be trying some on your own that aren't quite so much. All right, so if you tried them on your own and you got confused, that's okay. We'll do lots of them. So finding the absolute value. Absolute value means strip the sign. Just drop the sign. Drop sign. So 2.5 does not change. There is no sign shown. It just stays 2.5. Negative 3, drop the sign, so it's just 3. 3/8, drop the sign, it's just 3/8. No sign here, so just keep that as is. No sign shown, don't worry about it. And 0, absolute value of 0 is 0. There's no sign already, it's right on the dot. All right, so now we're going to do absolute value. What is absolute definition-wise? So here I want you to write in a definition or explanation. All right, so the absolute value of negative 13 is just 13. Oops, I didn't finish it. So hopefully I have an explanation here. I kind of jumped the gun. Absolute value. I would like you to write in, it's a distance from a center point. Distance from a center point. I'm going to write this a little nicer. Often we consider it being 0. Okay, so here's what absolute value of negative 13 is 13. 2, absolute value of 21 is just 21. Number 5, I'm going to do a few of these, and I'm going to expect on the pear deck that you'll finish those out for me. This next one, I'm going to do the absolute value of negative 12 is 12. plus the absolute value of 15 is 15. Add those together and I'm going to get 27. So I want to see your work. Number 9, I've got 15 minus 23 inside the bracket. So basically, if I were to find the difference between 15 and 23, I'm going to get 8, and it would be negative, so it would be negative 8, but the absolute value of negative 8 is just 8. I'll do number 7 here. Absolute value of negative 11 is 11. Absolute value of negative 5 is 5, but I have a subtraction sign in between, so 11 minus 5, which is 6. Show your work and finish the rest of those for me. All right, finding opposites. Okay, that's different than absolute value. Absolute value is distance from a center point. Drop the sign, and it's distance from a center point. Opposite means change the sign. So if it's negative, you're going to make it positive. If it's positive, it becomes negative. So the opposite of negative x minus 2 is going to be, excuse me, 3 minus 2, 3.2, excuse me, is going to be positive 3.2. Opposite of 5 is going to be negative 5. Opposite of 7/3 is going to be negative 7/3. Now, this is a tricky one. 0 is just 0. And the opposite of negative 8 is going to be positive 8. So negative x equals negative x equals negative x equals negative x equals negative x equals. All right, then the next part here we have order rational numbers. To order the rational numbers, we're going to, if they're not in nice, pretty numbers, we're going to put them all into decimals and then order them. In this case, they're all plain numbers, nice numbers. So let's just plot them on the number line. So 2 is going to go right here. Negative 3 is over here, and 0 is here. So in order, they're going to be negative 3, 0, and 2. Number 2, same idea. We're going to go here. This is negative 8. Well, that's negative 4, and that's negative 8. So this is negative 6. So negative 5 is right in here. It's kind of tricky, huh? Negative 5. So label that as well, negative 5. And then positive 7, here's 4, there's 8, so that's 6. So 7 is in between here. So in order, it's going to be negative 8, negative 5, and then 7. My number 9, I'm going to plot my dots. I've got negative 9 here, negative 12 here, and positive 6 here. So in order, it's going to be negative 12, negative 9, and then positive 6. The next part is tell whether the number in the list is a whole number, an integer, or a rational number. Then order the numbers from least to greatest. Okay, so each number in the list. Well, let's try it like this. I'm going to say negative 1.9, and that is rational. So I'm just going to put the letters. So Q equals rational. Remember, Z is equal to integer. And W is equal to whole. Whole, integer, or just rational. Okay, so this first one is going to be rational. Oops. And the next one's rational. The next one is a decimal, but it's rational. And the next one's going to be an integer. It's rational, but it's also an integer. And then I'm going to order them from least to greatest. So if it helps to put them on a number line, do so. I'm going to put here negative 3, my negative 1.9, 3/4, well, here would be my 0 in here somewhere, right? That would be like your 0. And then I would have, so negative 3, negative 1.9. I've got 0.75 and 0.8. So I'm going to do 3/4, and then I'm going to do 0.8. So in order, it's going to be negative 3, negative 1.9, 3/4, and then 0.8. Number 5. I'm going to put these in order. I'm going to go ahead and use a number line just because. I'm going to have negative 2. That takes care of that one. Then I have the 0, because 0 separates the positives and the negatives. I'm going to have 1/2, and then I'm going to have the 1.3. So negative 2, 0, 1/2, and 1.3. Now, classifying them, I'm going to classify them in different color. I'm going to say this is rational. This is an integer and rational, so Q, Z. 1/2 is rational, Q. And 0 is a whole number. It's an integer. And it is rational. Number 6, 2.5. 2.5. It's not natural. It's not whole. It's not an integer. It's got to be just rational. Q. Fraction. So it's going to be Q. That's a decimal. It's going to be Q. And it's a fraction. It's going to be Q. All right. So they're all rational numbers. Now let's go from least to greatest. So here we go. The smallest is going to be my negatives. 0.78, or 7/8, excuse me. 7/8 is actually a decimal. On your calculator if you need to. If you need to pull it up, I know some of you will already do it. It's going to be negative, but it's 7.8. And this is, or excuse me, not 7.8, 7 divided by 8 on your calculator. Which ends up being negative 0.875. So on my number line, I'm going to say this is my 0, and I shouldn't put the 0 on here. I'll just put the line for the 0. If that's my 0, my negatives are behind here. So negative 87.5 cents or negative 1/2 cent, meaning you have less money. If the more negative you are, the less money you have. Okay, more in the hole you are. So I'm going to go back here and say this is going to be my my negative 7/8. And then I'm going to have my negative 0.5. So check, check. On the other side, this is 1/3. It's not even had a whole number out front. So if this is my 0, I'm going to have 1/3. And then I'm going to have my 2.5. And mine are approximates on the number line. They're not perfect by any means. My spacing is not at all correct. So in order, I'm going to say negative 7/8, negative 0.5, 1/3, and 2.5. We're almost done with this full lesson. Getting close. So for the given value of A and negative A and absolute value of A. Okay, so for the given value of A, find opposite of A equals and absolute value of A equals. So this would be negative negative 10.2. And this would be the absolute value of negative 10.2, which would give me 10.2. And 8. I want negative A, which would give me opposite of that, so negative 14, which negative A is going to be equal to negative makes a positive, so it's 14. Absolute value of A is equal to absolute value of negative 14. So absolute value of A is equal to 14. And the last one, opposite of A is equal to negative 1/2. Absolute value of A is equal to absolute value of 1/2, which is equal to 1/2. So conditional statements. I want you to identify the hypothesis and the conclusion of each conditional statement. Well, I will remind you that we have an if blank, then blank. This is the hypothesis, and this is going to be my conclusion. And then you need to tell me whether it's true or false. So if a number is negative, then its opposite is positive. If the number is negative, then its opposite is positive. Okay, so we're looking at the word opposite here. So identify the hypothesis and the conclusion. So write those out. So I would write, this is the hypothesis, and this is the conclusion. And if it's negative, the opposite of a negative is positive. Tell me whether it's true or false. If a number is even, then the opposite is a whole number. Underline the hypothesis and the conclusion, label them, and tell me if it's true or false. So true or false, and then underline it and identify for me. Do those in your Pear Deck, please. The genie offer. Here I'm going to make you think. Okay, so we're thinking about the cute little genie, and we're going to say the brass bottle that looks really old. When you rub the dirt on the bottle, a genie appears. The genie offers you a reward. You must choose one between the $50,000 or a magical dollar coin. The coin will turn into 2 coins on the first day. The 2 coins will turn into 4 coins on the second day. 4 will double it to 8 on the third day, etc. It will continue for 28 days. What's your choice? So write down either the $1 coin or the $50,000. So 50 grand or $1. And then show me. You have to show me how you know this. Use your Pear Deck. At any time you can pause me, remember that. All right, so now we're going to make some 16. We're going to make 16. So as we make 16, here are some expressions. All but one of them is equal 16. Find the one that is not equal to 16 and explain how you know. So remember we talked about like exponent. Exponent means it's how many times you multiply the base by itself. So this one is actually 2 times 2 times 2 right here, times 2. So 4 times 2 is 8, times 2 is 16. 4 squared, 8 squared, and 2 to the 5 halves. This one I'll kind of give you a little tidbit. It's squared, and it's going to be to the 5th. So basically this means this is a root. It's your base, it's your root. So it's a square root of 2 to the 5th power. So you're going to have to find out what 2 to the 5th power is in here and then square root it to give me your value. All right. The next part is I want you to write 3 expressions containing exponents so that each expression equals 81. So you have to use the same, you have to get some combination of numbers with exponents to get me 81. Give me 3 expressions on your own. On your own. Show it in your Pear Deck, please. The next one is the cube has a side length of 10 inches. Jada says the surface area of the cube is 600 inches squared, and Noah says the surface area is 3,600 inches squared. Here's how they reasoned. So I need you to look at these two, Jada's and Noah's, and then do you agree with either of them, yes or no, and then explain your reasoning. Refresher, that is an on your own, so make sure you complete that on your own. I'm going to call it try on your own, so do it on your own. Okay, now we have expression explosion. This is probably where you're going to like the order operations a little bit better because you can actually work with just exponents and it's multiplying or dividing. I'm going to do the first one on the left. I'm going to do this one for you. And I'm also going to do this bottom one for you. That'll give you an idea of what the other side should look like. So if you look at my notes over here, work one column and then the next. So work the left, and the answers on the right should actually match up with the ones on the left. Show your work, please. So this first one, we're going to do 5 squared. 5 times 5 is 25. Plus 4 gives me 29. The bottom, and again, please try not to use your calculator. Try to do it on your own. Down here, this bottom one, the only reason I'm doing it is to show you how to work with that fraction piece, because you're going to have to do the one over on the right-hand column on your own. So this is 1/9 times, and this cubed means 1/2 times 1/2 times 1/2. It means 3 of them. Okay, this is one option of way to do it. And multiplication, you just start multiplying the tops, multiply the bottoms, and then you're done. So 1 times 1 times 1 times 1, 1 over 9 times 2 times 2 times 2. Or you can multiply in any order. 2 times 2 times 2 is 8 times 9 is 72. That was a little bit fast. Rewind me. Listen to me again. Another way to do this, though, I will share with you. Another way is to cube the top and the bottom. So I could say it's 1/9 times 1 cubed over 2 cubed, which makes it 1/9 times 1 cubed is 1, because 1 times 1 times 1, and 2 times 2 times 2 is 8. And then I end up getting back to the same exact answer. Either way, show me your work. Questions? Email me.